All right, we're going to start our discussion on finance by just talking about percents for a few minutes. Percents are really the foundation to finance in general. A lot of the topics that we're going to deal with money are going to deal with percentages. Your different interest rates, your tax rates, discounts at a grocery store. All these things are percentage based, and so that's really the foundation of this financial portion of the course. So we start out with percents. Now, I assume you've all worked with percents, even at a very basic scale or basic level. But what we're going to do is we have to learn how to convert between fractions, decimals, and percents. Again, I assume you know a lot of this, but I'm just going to review very briefly. And then we're going to solve some very basic percent equations. Okay, so percents in general mean parts out of 100. That's basically your definition of a percent. So 50% is 50 parts out of 100. 33% is 33 parts out of 100. Okay, so you're basically thinking about things in terms of hundreds. And so percents are nice for that reason. And I guess maybe for some reason in our brains we like the number 100. Okay, I don't know, but we get a feel for different values based upon their portion out of 100. Okay, so when we're looking at converting percents, if I wanted to take a fraction like 2/5 and convert that into a percent, I'm looking at what percent of 5 is 2, right? If 2 people fail the course out of 5, there's 5 people in a course. Well, I have had some, but if you had 5 people in a course and 2 of them failed, what percent is that, right? And so these are the kinds of things we'll be looking at. So to make that conversion, the first thing you do with a fraction is you always turn it into a decimal first. Now, turning this into a decimal can be done in a variety of ways. You could use a calculator, just type in 2 divided by 5, and you get 0.4. Or you could turn it into a fraction with a 10 on the bottom. You could multiply by 2, build the fraction up, you get 4/10, which is 0.4, because your tenths are your decimals. Or and that's usually what I do if the bottom works out nicely. If it's a 2 or a 5 or something in the bottom that works out nicely. If it's not, then you just have to do a division, long division. You do 5 on the outside, a 2 on the inside, and 2 is equivalent to 2.0, and I'm going to need extra decimals to make this work. So I'm going to put 2.0 in there. 5 goes into 2 0 times. 5 goes into 20 4 times, and you move the decimal straight up. It's a bad looking arrow. That's an arrow. Okay, move the decimal straight up. You get 0.4. 4 times 5 is 20. Subtract, you have a 0 remainder, and so that's it, right? So 0.4. Now, once you've converted it into a decimal, 0.4, the conversion to a percent is moving that decimal place 2 places to the right. You're essentially multiplying this by 100, all right? And so that's equivalent to 40%. So if 2 people failed out of 5, 2 people failed out of 5, that's 40% of the class failing, okay? And so that's the way you want to convert those. So going from a fraction to a percent, you have to kind of hit that intermediate decimal portion first, and then move the decimal over. So you move decimal point 2 places right, and that will convert your decimal into a percent. And that works for any decimal, okay? If I wanted to convert 0.052 to a percent, well, again, I just move that decimal 2 places over, and that's 5.2%, okay? If I wanted to convert it to a fraction, I could do that too. Sometimes you want to make those conversions. To convert that to a fraction, I could call it 52 out of 1,000. That's 52 thousandths, right? Tenths place, hundredths place, thousandths place. I always remember it as the number of the number of digits after the decimal should equal the number of zeros on the bottom there. And then you can reduce this fraction. So if I divide by 2 in both cases there, I'm going to get, what is that, 26 out of 500. I can continue to divide or reduce this down. Divide by 2, divide by 2. I could have picked a larger number than 2 to start off with. I would have gotten there faster, but this is 13 out of 250. Right, so 5.2% is the same as 13 out of 250. And of course, if I started with the 13 out of 250, I could do that division, 250 into 13, tack on a 0, and what you'll find out is it's 0.052. Okay, so just to show you kind of how you can bounce back and forth between these. So with every number, there's a fraction form, a decimal form, and a percent form. Okay, and these, it could be any number even bigger than 1, right? So 100%. So you could have 32 out of 15, right? 32 out of 15 is a fraction. If I want to put that into a decimal, I just go 15 into 32. 15 goes into 32 twice with a remainder of 2, but then I can just keep going until this works out to end. If it does end, and it doesn't actually, it's going to be a repeater. That's okay. 15 goes into 20 once. 1 times 15 is 15. Get a 5, bring down another 0. 15 goes into 53 times. 3 times 15 is 45. And you're going to get a 5 there, and it's going to repeat at that point because I'm just continuing to bring down a 0. Get a 50, 45, 0, 50, 45, and so forth. So that's a repeater on that 3. Okay, so that is 2.1 with a repeating 3. And that's the decimal form. Now the percent form, if I move that decimal 2 places to the right, remember this 3 will repeat. It's going to keep going on. And so the percent form is 213%, 213.3%, because I'm going to put that decimal over there. I've still got more 3's going to the right. So it's an infinite list of 3's. So I just have 213.3 repeated percent. Right? That moves the decimal over twice. There are also times where you start with a percent and you want to turn it into a decimal or a fraction, but usually a decimal in our case. And so if I had, let's say 0.12%, a lot of times our interest rates are very, very low, okay, less than 1%, less than 1 part out of 100. Let's say it's 0.12%, then to convert that to a decimal, you would have to move the decimal point to the left 2 places, so the opposite direction, and you end up with 0.0012. Okay, so that would be the decimal form, and of course the fraction can be found taking the 12, dividing it by, 10 hundredths is 10,000. Again, the number of places after the decimal equals the number of zeros on the bottom, and then reduce. Here I probably divide out a 4, and that gives me a 3 out of 2,500. Yeah, 3 out of 2,500. Okay, so that would be the same as 0.12%. So anyway, these conversions are interesting. Now, what you may also see is you can combine these into a table, so it's not just all scattered all over the place. But if I wanted a fraction, decimal, percent table, we could do that. And each row is an equivalent value, and each column I throw a number in there. So maybe for the fractions, maybe I give you 3/4 as a decimal. Maybe I give you 0.62, and then maybe as a percent, I don't know, I'll throw in there 12.5%, maybe something like that. And so then the idea is in each row you try to find equivalent values to fill in. So for 3/4, I need the decimal and the percent form for that. Okay, well, 3/4, most of you probably know that that's 0.75, right? It's 3/4. If you think about that in money, it's 75 cents. Or you could do the division. You could do 4 into 3, throw a 0 in there so you have some decimals to work with, and you get 0.75 when you work it out. I won't go through all the details. And then as a percent, of course, you move your decimal over twice and you get 75%. So 3/4 is 75%. 0.62, well, as a percent, that one's easy. It's just 62%. Move the decimal twice to the right. As a fraction, I've got a little work to do. 62 out of 100, right? Number of places after the decimal equals number of zeros on the bottom, and then you reduce. I would divide by 2 on both of these. That'd be 31 out of 50. 31 is prime. Can't divide it. Can't reduce it any further. So that's 31 50ths. And then 12.5%. Of course, if I wanted a decimal form, I move the decimal left. That would be 0.125. And then as a fraction, I just divide, 125. So 125 by 1,000, right? I've got 3 decimal places there. I've got 3 digits or 3 zeros on the bottom. And so at this point, I need to divide. I'll divide by 5, see what happens there. 125 divided by 5 is 25. 1,000 divided by 5 is 200. I could divide by 5 again. 25 divided by 5 is 5. And 200 divided by 5 is 40. And of course, if I divide by 5 one last time, I'm going to get 1/8. Is that right? Yeah, 1/8. So my fraction there is 1/8. Now the nice thing is that when you have 8s, they terminate nicely. 0.125, 0.375, and so on. So 8s are nice, 4ths are nice, halves too, right, on the bottom, those are nice. 50ths, anything that divides into 100 nicely, right? 25 on the bottom, 5, 10, okay. So those are some nice numbers when they work out well. Anyway, so this conversion is very important. The other thing that I really want you to, this kind of base level understanding of percents, is to be able to convert and solve percent problems. So just, being asked a question like, what is 30% of 72, for instance? Okay, offhand I don't know, but I can figure it out. What is 30% of 72? Well, to figure that out, we're going to use an equation. The equation generally is the amount is equal to the percent times the base. So amount, percent, and the base. Now the base, as a general rule, it will follow the word of in the sentence. So, this is really just a translational issue. We're just kind of like when we did with logic, is we're taking an English sentence and we're translating it instead of into a logical, a logic statement or a symbolic logic statement, we're going to translate it into a mathematical equation. And so the base always follows of, okay? And you'll see the word of in pretty much every one of these, okay? And so the percent of something. The word of means multiply, right? So that's where we get this multiply from. So the amount is the percent times the base. So, and then the word is the equal sign, okay? The word of is your multiplication. So in the sentence, you're looking at the amount is equal to 30% times 72. 30%, you want, in order to actually use that, we need to put it in decimal form. So it's 0.3, right? Move the decimal 2 places left. So the amount is really 0.3 times 72. And then we just multiply them together. Now sometimes I have to solve, because maybe it's one of the ones on the right that I don't know, but right now it's the A that I don't know. So I multiply those together, and of course 72 times 3, and then I'll put the decimal in after the fact, is 216, right? 3 times 2 is 6, 3 times 7 is 21, and I need one place after the decimal, so it's 21.6. So the amount here is 21.6. That's the answer to my question. 21.6 is 30% of 72, okay? Question could be asked a little bit differently. You could ask it in a different order. It could be, 30% of 72 is what? You could switch things around a little bit. That's not too bad. What I'm more interested in is putting the unknown quantity in a different location. So you could say something like 15 is what percent of I don't know, 108, something like that. 15 is what percent of 108. And so again, amount equals percent times base. The percent is what's unknown. That's where our question word comes in. The 15 is the amount. The base, again, immediately follows the word of. Okay, so we get 15 is equal to the percent times 108. Now, how do I solve this equation? I'm sure you've all solved equations before. Here's just a one step. You divide by the 108, okay? So you have the percent. No, okay, let's do it this way. Let's show that division. You divide by 108 on both sides of the equation. It cancels off on the right. And so the percent is 15 over 108. And of course, that's kind of a weird way to write a percent. You want to convert that. So here's where our conversion is important. We divide. Now, one thing I noticed, if you think back, this will make things a lot easier. Who wants to divide 108 into 15, right? It's going to be tedious, but here's where some of our number theory is going to be important. Notice both of these are divisible by 3. Our divisibility rules are very important here, right? If I add 1 and 5, I get 6. If I add 1, 0, and 8, I get 9. Both are divisible by 3. So both numbers are divisible by 3. I could reduce this very quickly. 15 divided by 3 is 5. 108 divided by 3, well, 3 goes into 10 3 times, right? That gives me a 9, gives me a 1 remainder, and then that means there's an 18 left, the 1 remainder and the 8. That's 18 divided by 3 is 6, so there should be 36. Okay, I'm doing that without doing the full long division process, but you could use a calculator too. And so I could do 36 into 5. It's going to be quite a bit simpler. It goes 1 times 36, remainder 14, bring down another 0. 36 goes into 140. It's not quite 5 times. It's probably 4 times. 4 times 6 is 24. 4 times 3 is 12, it'd be 14. Oh, it's 144, really? Popped it right over 1 by 1, or by 4 units. So I actually need 3 there. So 3 times 6 is 18. It'd be 10, 108. Oh, yeah, 3 times 36, right, is 108. And then, that's 32. Another 0. 36 into 320, well, 36 into 360 would be 10. This has got to be less than that by 40, so it'd be 2 less, it'd be 8. 8 times 36, I should have brought my calculator in here, but we're going to get through it. 3 times 6 is 48. 8 times 3 is 24 or 28. And when I do that subtraction, It's 32. Oh, I see a repeater here. Is that a repeater? Oh, sure it is, because it has a, yeah, it has a 9 as its, or a 3 as its factor, so there we go. So we've got a repeater at 8, 288, and so forth. All right, so the decimal form is 0.13 with a repeating 8. And so the percent form is 13.8 repeating percent. All right, so there's our percentage. There's our answer to our question. 15 is 13.8 repeated percent. You could also think of this, that repeater of an 8 is really 8 ninths. So it's 13 and 8 ninths percent. Right, anything divided by 9 is that number repeated. So that's another way to write it out. Okay, so anyway, that's the other question. Now there's one more question, one more position you could have a variable. So instead of the amount or the percent, you could have the base being unknown. So you could do, let's say 45 is, I don't know, 45 is 28% of what? Let's see, this is gonna be ugly. It's gonna be a nasty decimal, I think. We'll see what happens here. So again, we translate. So we've got the is equal, the what is the base. So that leaves, this is the A and this is the P. 45 is A, 28 is P. So you get 45 equals 0.28 times the base. To solve for B, you have to do a division by the 0.28. All right, you have to do that division. And so, now this is kind of a weird division. Of course, calculators are useful right here. I don't have it on me, so I'm just going to do the longhand division, and I think it's useful to see these longhand divisions. I know I'm running through them quickly, but you don't always have a calculator with you, right? Let's see, so 0.28 goes into 45. Well, yeah, I will. 28. Now, what you need to do is, if you recall how to divide with decimals, you've got to move the decimal on the outside so that this is a whole number on the outside. So I need to move this decimal twice over. To do that, I also need to move the one on the inside over and then bring it straight up. Okay. So basically you're moving both decimals on the fraction is multiplying the top and bottom by 100. So it's an equivalent fraction. You're just multiplying top and bottom by the same amount, and that's what moves the decimals. And so then I take 28 into 45 once, right? Yeah, that's 28. What's that, 17? Bring down another 0. 28 goes into 17. 4, 5 or 6 times maybe. 6 times 8 is 48. 6 times 2 is 12, and 4 is 16. That's perfect. Remainder 2. Bring down a 0. Yeah, 28 goes into 20 0 times. 0 times 28 is 0. I said 28. Got a 0. Bring down another 0. 28 goes into 200. Well, 6 gave me this. Probably need 2 more. No. 1 more. So it'd be 7. 7 times 28. 7 times 8, 56. 7 times 2 is 14. That'd be 19. Remainder 4. Bring down another 0. And you can see how this is going to develop. I'm just going to go 1 more decimal place and then we'll round it off. That'll be good enough for my purposes here. So 28 goes into 40 once again. And 1 times 28 is 28. And now the rest of this doesn't really matter because I have my decimal that I can round the 7 with. And so I know the 1 rounds a 7 down to a 7 rather than up to an 8. Okay, so my answer then for B is going to be 160.7. Now I shouldn't use an equal sign there because they're not exactly equal. I did round, and that's an important aspect here. So I'm going to say it's approximately equal to 160.7. Yeah, it's close. Now it's not exact. There's a lot of other decimals in here that are important. But for what we're doing, I'm just going to round it off so it can be done. Okay. Most of the ones you'll see will terminate nicely or will repeat nicely, like this one. Otherwise it'll tell you where to round it off to. All right. Or it may just be that rounding is necessary for a finance problem where money is involved and you just need to round it to the nearest penny, right? So like $52.36 or something like that. And so you round it off there rather than keep going. So somewhere that's reasonable for the problem. Okay, so anyway, this gives you your 3 different types of percent problems. One of them is where the amount is missing, one of them is where the percent is missing, and one is where the base is missing. And so the equation is the same. The A equals P times B is the same equation. It's a one-step solution. And so you're either going to, the one that I erased, you're either going to multiply the percent and base together to get the amount, or in these other 2, you divide the amount by either the base here or by the percent here. Okay, so two of the variations have a division, one of them have a multiplication. You just need to know which one's which simply by translating and understanding what parts of the equation correspond to what parts of the sentence.